is in group 6A. Now, before I sum those together, we have an extra piece to deal with for this. This is just what would happen if I had 1 nitrogen and 3 oxygens. But what do I actually have? I actually have a minus charge. That means somehow this nitrogen and these 3 oxygens picked up an extra electron. Well, I need to deal with that actual negative charge. That negative charge really means I have 1 more electron than just what the atoms on their own brought to the table. So now I can total these up. 6, 12, 18, I'm looking at 24 valence electrons. Just like anything else, determine the central atom. Usually it's the first one listed. No exception here. Here I'm dealing with nitrogen. Oxygens are going to be my outer atoms. Next step, complete an octet of electrons around those outer atoms by making lone pairs. So that's going to be 3 lone pairs around each outer atom. Remember, I got 24 from this charge, that extra electron. If you had a -2 charge, you'd have 2 more electrons. A -3 charge, 3 more electrons. So 24 electrons. Let's see how we did. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I have my 24 electrons. Now I'm also looking for octets. This oxygen, 2, 4, 6, 8, that's good. This oxygen, 2, 4, 6, 8, that's good. This oxygen, 2, 4, 6, 8, that's good. Nitrogen, 2, 4, 6. So here again, I'm in the situation where I have the correct total number of electrons. There's 24 in here, but I don't have octets around everything. So here, in order to get an octet on that central atom, I'm going to pick one of the outer atoms, take one of the lone pairs from that outer atom, and move it in to make a multiple bond. Make another bond with that central atom. If I draw the result of that, keeping everything else the same except for the 2 electrons that I wanted to move, I would get this structure here. Again, no real reason to not be sure if you did it correct. You should always be doing these checks. 24 electrons still. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now let me check the octets. 2, 4, 6, 8. 8 around that oxygen, that's good. This oxygen, 2, 4, 6, 8. 8 around that oxygen, that's good. This oxygen, 2, 4, 6, 8. 8 around that oxygen, that's good. The nitrogen now, this was the problem in the top structure. 2, 4, 6, 8. Nitrogen's now good. So now I have the correct structure. There's one extra thing we want to do with this structure. Let's just kind of give a little reminder that we're dealing with an ion here. This had a charge. So sometimes when things have charge, what we do is we put the whole thing in brackets and put the charge outside the brackets. That just lets people know, hey, this thing has a charge. We don't want to just put it in without brackets because we really want to get at the idea that that charge is owned by the entire polyatomic ion. It's not owned by one specific piece. Now I'm not going to draw out these structures, but what you're going to notice is I had choices here as far as which outer atom to make the multiple bond to. Just like I did for the SO2 previously, I would have resonance structures to write for this, or that could be written for this. I would have a resonance structure where I'd have the double bond on the bottom oxygen. I'd have a resonance structure where the double bond would be on the right oxygen. I'd have a total of 3 different resonance structures for this. This, due to kind of the space we have, I'm not going to show all the resonance structures for this, but I want to show you in this example what you're dealing with when you have a charge. If you have a negative charge, you need to add on electrons. So the last structure I want to do for this first part of the video in terms of dealing with Lewis structures is I showed you what happens to negative ions. What would happen with a positively charged ion, something like the ammonium ion? Well, the ammonium ion, I still want to sum up the piece. I have one nitrogen, 4 hydrogens. Nitrogen comes in group 5A. Each hydrogen comes in group 1A. But I have a plus charge. What does that plus charge really represent? This plus charge really says I have one less electron than just what the nitrogens and the hydrogens were bringing into the mix here. Well, for that, I need to subtract off an electron. I lost an electron in this mix. 5, 6, 7, 8, 9 minus 1 means I'm going to deal with 8 total electrons I need to deal with. Just like before, determine the central atom. Usually it's the first one listed. This is no exception. Nitrogen is going to be that central atom. Hydrogen is going to be the outer atoms. Make a single bond connecting each outer atom with the central atom. Check and see how you did. I need 8 electrons. Well, no lone pairs on hydrogen, so now I'm at the stage of just checking these. 2, 4, 6, 8. I have 8 electrons. Checking for octet and duet rules. Hydrogen's not going to follow the octet, it's only following the duet. 2, 2, 2, 2. The nitrogen, though, should have its 8. 2, 4, 6, 8. It has its 8. Here, I'm looking at the correct structure. One last thing to finish this one off, because I do have a plus charge, I'm going to put my structure in brackets, put that plus charge outside of those brackets. So when you have a positive charge, subtract off an electron. Remember, electrons are negatively charged. If you have a positive charge, you've lost an electron, one less electron. What we saw for the NO3 minus, if you have negative charge, you have to tack on additional electrons. So this is going to be the first part of our video on drawing Lewis structures. We're going to have a second part. Lewis structures are kind of really important. In the second part, we're going to look at dealing with some more exceptions to the octet rule, and along with some more advanced techniques to really get at writing really good Lewis structures.